Okay, here's another interesting one. This says cosine of 2t equals cosine of t. Well, holy cow, that's kind of interesting. I wonder what that could be. I wonder what we could possibly do with that. How could we solve that? Well, we did encounter a problem earlier that had a sine of 2t. We were able to get that equal to a constant, and then we figured out what angle 2t had to be, and then we just divided those angles in half. But in this example, it's not that easy because we can't just get cosine of 2t equal to a number because it's equal to cosine of t. So what could we do instead? Well, what we can do instead is, again, apply a trigonometric identity to simplify this. What we want to do is get this in terms of cosine of t. Not cosine of 2t, but cosine of 1t. And the way to do that is to use a double angle formula. So cosine of 2t can be written as, there's a few different possible double angle formulas for cosine of 2t, but one of them is 2 cosine squared of 1t minus 1. So that trigonometric identity, the double angle formula for cosine, giving us 2 cosine squared minus 1, we make that substitution here. And now we can perform a u substitution like we did in the last problem with u equals cosine. So we get 2u squared minus 1 equals u. And then we can just subtract the u from both sides. 2u squared minus u minus 1 equals 0. And then figure out what the solutions are going to be here. So we've got, let's factor that. We're going to have 2u plus 1 and u minus 1. Okay. So two solutions for u. U is negative 1/2, and then u is 1. And now we have to go back to cosine. Remember, u is equal to cosine. So cosine of t equals negative 1/2, or cosine of t equals 1. And both of these have solutions. Okay, so from cosine of t equals negative 1/2, over here, at negative 1/2 on the x-axis, we have two solutions here and here. Those would be, let's see, at negative 1/2, those are going to be, we're talking about multiples of pi over 3 here, so 2 pi over 3, and then 4 pi over 3. There we go. And then on the other one, cosine of t equals 1, when x equals 1, we're over here at this point, and so we're talking about t equals 0. And that's it for that one. So that's how you can solve something like that. So again, for that one, we applied a trig identity, and then we're able to do a substitution and solve a quadratic. So let's do one more. I think this is our last example for this section. This section is full of examples. I kind of enjoy doing these ones where I just get to teach the entire lesson by simply showing you a bunch of examples. What I'm trying to do here is just show you a bunch of different types of situations you could encounter when you're trying to solve equations involving trig functions. And I'm trying to give you a bunch of different strategies that you can employ. And then when you go out and start solving trig equations, you're just going to have to kind of approach it with a little bit of creativity and think, well, I've got all these different tools and ideas and strategies that Tristan has shown me, or that I've read on, in the book, or seen on videos on YouTube, or from friends or whomever. And so you just got to decide, well, which strategy seems most useful, and then you try things, and sometimes they don't work, but that's okay. I mean, over time you'll start to learn which strategies are most effective for which different types of equations, and then eventually you'll be like me. You'll just be able to look at the equation and be like, oh, I think in this situation I need to do this thing. And then you try it, and if it doesn't work, it doesn't work. But you try something else. But if you know what you're doing, often it works because you recognize the situation and you knew which tool to apply. It's like sorry, this is a long tangent. It's like a mechanic. Fixing a car or some other machine. They have all these tools in their toolbox, and an amateur wouldn't know which tool to use. Right? They would see something broken or whatever and think, oh, I don't know what tool to use. I've never seen something like that. And they might try a bunch of tools, and then the first 10 of them don't work. But an experienced mechanic sees something broken, and they might know exactly which tool to use, and they pick out the perfect tool and they use it, and it works right away. So just like that, it just takes experience. So all right, let's solve this equation. Tangent of x equals 3 times sine of x. The first thing I want to do with this is go ahead and write it in terms of sine and cosine. So tangent of x can be written as sine of x over cosine of x. This is a really useful thing to do. If you don't know what else to do, and there are trig functions involved other than sine and cosine, then just write everything in terms of sine and cosine. Okay, use all those reciprocal and quotient identities. And then, the next thing I want to do, I think, because I'm still not quite sure what to do here, the next thing I want to do is subtract everything from one side and get this equal to 0. Minus 3 times sine of x, all equals 0. Okay, this is another good thing to do. Getting an equation equal to 0 often makes the equation easier to solve, because if you can factor what's over here on the left, then you can use the zero product rule, and that's a great path to take towards a solution. Now you might be wondering right now, hey Tristan, back in the previous step, why didn't you just divide both sides by sine of x and cancel it out? Because you clearly have a sine of x on both sides of the equation, so it shouldn't cancel? Yes and no. The danger with that is that sine of x could equal 0. So dividing both sides by sine of x would give you would be like dividing both sides by 0. But if sine of x was equal to 0, you'd have 0 equals 0, which would produce some solutions. And indeed, if we take the other strategy that I'm demonstrating here, and if we go ahead and factor out sine of x, then using the zero product rule, one of the possibilities is that this sine of x factor would equal 0, and that would cause the entire product to equal 0. So the danger with dividing both sides by sine of x and then canceling it out, the danger from that is that you might forget about the possibility that sine of x could equal 0, which would then give you some solutions. So you might forget to actually find those solutions, and then when you think you're done, you actually missed a few. So that's the danger. I just recommend generally not dividing both sides and canceling by any expression that involves x. Never ever do that, just as a rule of thumb, because it does tend to cause problems in different types of problems in different situations. So instead, it's better to factor. So we factored out sine of x. One possibility is that sine of x equals 0. That, if sine of x equals 0, talking about the y-coordinate being equal to 0, which means we draw a line right here along the x-axis, and that would give us 2 points on the unit circle, one over here and one over here. And those would be t equals 0 and t equals pi. So there are two solutions to our equation. The other possibility, of course, is that this factor equals 0. So if 1 over cosine of x minus 3 equals 0, then 1 over cosine of x has to equal 3. So cosine of x has to equal 1/3. I get that by just reciprocating both sides of that equation. So that should give me some solutions as well, right? Cosine x equals 1/3. There should be two of them. It should be, if I find 1/3 here on the x-axis, I'm going to have a solution up top and a solution down on the bottom. One in quadrant 1, another in quadrant 4. But 1/3 is not a number that is a common angle, coordinate for a common angle, right? So this is another one of those situations where I have to resort to using my calculator. So I'm going to do, first of all, the cosine inverse of 1/3, and I'm in radian mode right now, so this will give me a radian value. So one possibility is that t equals 1.23 radians. And which of these 2 points does that correspond to? Well, remember that the arc cosine function that we're looking at here gives us solutions in that interval right up there. So that means that this value corresponds to this point. And if I want the other point, what I can do is, instead of measuring up, I can measure down, like that, by subtracting that arc cosine of 1/3. Except what am I going to subtract it from? I'm going to subtract it from, I want something in the interval 0 to 2 pi, so I'm not going to subtract it from 0. I'm going to loop around the circle all the way and then subtract back. Just dial that back a little bit. So I go all the way around to 2 pi, and then I dial that back by the same angle that we got the first time. So I'm going to do 2 on my calculator. Watch, I'm going to do 2 pi and then minus that arc cosine of 1/3. And that should give me the other angle, which is 5.05 radians. So in this instance, we got 2 solutions which we could calculate exactly using, doing it sort of by hand, because they're on the unit circle, and then 2 solutions that we had to approximate because they're not on the unit circle. So we had to resort to the calculator. So that's the last example for this this section. It's all about solving equations. That's pretty much all we're doing here. And I think that about wraps up chapter 9. So next thing is the law of sines and the law of cosines.